Welcome. Glad you can make it. I'm your supervisor, Brian. Is this your first time working with robots? No problem. I'll help you get started and guide you through everything you need to know and do. Let's go inside. This is the robot you'll be working with, a UR-20. Before you get started, I'll give you a quick overview of the robot hardware and software. Let's start with the Teach pendant. You use the pendant to power up the robot, to program it, and to load and run programs. Push the power button to turn it on. The next step is to initialize the robot. Click the red circle icon in the lower left corner to do so. And click On to enable power for the joints. And click On to enable power for the joints. Now, there's power for the joints, but the brakes are activated. To release the brakes, you need to press one of the two yellow switches that are placed on the back of the Teach pendant. Now, press and hold the switch button. If you release the switch and press it again, you'll notice that the button has three positions: released, light press, and tight press. This is a safety function to avoid unintended movement. On the Teach pendant, you can see that the Start button is deactivated when the switch is released or in the tight press position. To enable the release of the brakes, press the button to the light press position. Keeping the button at light press, you can now click the Start button. The clicking sound you hear is the robot releasing its brakes. It's now initialized and ready to operate. Click the Exit button to proceed. Then click the Program button in the header. This is the screen where the robot program or program tree is displayed. Right now it's empty, but you can insert commands from the menu to the left. Try clicking the Move button in the left pane. Now you have a motion command and a waypoint in the program tree. You define the location of the waypoint by physically moving the robot to where you want to place the waypoint. To do so, click Waypoint 1 in the program tree, and then click the Set Waypoint button in the command window to the right. What you see now is the Move screen. From here, you have different options for moving the robot. The yellow color of the move arrows means that movement is not possible. This is also a safety function. To enable movement of the robot, you have to light press the switch on the back of the Teach pendant. Movement is now enabled, and you can move the robot as long as you keep the switch in the light press position. Try moving the robot using the up and down move arrows in the TCP position window. You can also hand guide the robot by enabling the free drive function. To enable the free drive function, first you must release the switch button. Then double-click the switch. Keeping the button at light press, you can now physically grab the robot and move it. Give it a try. Then click the OK button to save the robot's position as a waypoint. The robot's current position is now saved as waypoint 1. Of course, you need more waypoints to create a full program, and you'll get to try that a little later. Do you have any questions about the Teach Pendant before we move on to the control box? Yes, you can. There are several options for programming without the Teach Pendant. You can create a program in the offline simulator called URSim and transfer it to the robot. Or you can connect mouse, keyboard, and an external screen. That's the emergency stop button. If you push it, the robot immediately stops all motion. The switch is a safety device to protect the user. The purpose is to avoid unintended movement while being near the robot. If the programmer releases the button or tight press it, the robot immediately stops all motion. Yes, you can use URScript. It's a high-level script language based on Python. You can create a program using only script, or you can create a program in the user interface and add script commands whenever it's necessary. What you see here is the control board, which handles all input and output from the control box. Or, to put it another way, this is where communication to and from external devices is wired in. The green connectors are for analog I/Os. These can be used to set or measure voltage or current to and from other equipment. The 16 gray connectors are digital inputs and outputs for general purpose, such as sensors, conveyors, and PLCs. The 16 yellow connectors are configurable I/Os that can be used for general purpose, but can also be configured to work as redundant safety inputs and outputs. The yellow I/Os to the far left are dedicated redundant safety inputs. These are for connection of external emergency stop. And these are for safeguard stop, where you can connect devices such as safety scanners, light curtains, and the safety mats. Down here, we have the SD card, which contains the robot image, including the operating system, programs, and installations. To the right of the SD card, the Ethernet port is located. It can be used to communicate with external devices such as PLCs or other robots through common protocols like Profinet, Modbus, Ethernet IP, and TCP IP. Next, you have two USB ports. Here you can connect external storage devices to back up programs, installations, or the entire system. You can also insert a dongle if you want to connect a mouse and keyboard. The last port is a mini display port used to display the Teach Pendant on an external monitor. That's pretty much everything you need to know about the control box for now. Any questions before we continue? Okay, that was a short introduction to the hardware and software. Let's look at the task you'll be working on. Your task is to create an application similar to this one. The first robot picks bags from the pallet and places them on the conveyor. The second robot labels the bags. And the third robot places them on a pallet. You'll also have to program the conveyors and set up communication between the robots. We'll begin by preparing the robot that picks the bags and places them on the conveyor. Start by grabbing the vacuum gripper from the table and place it on the robot tool flange. Then, remove the lid from the tool connector and plug the cable from the grip. Next step is to rename the gripper in the software for ease of use. Click the installation menu in the header and I/O setup in the left pane. The gripper is connected to the output called Tool Out 0. Click this output and rename it to Gripper. Next, you have to turn on the power for the gripper. Click the Tool I/O button in the left pane. And click the drop-down menu below Digital Output Mode. Set the tool output voltage of this gripper to 24. Good. The gripper is now ready to operate. Next, you need a sensor at the conveyor to detect when a bag is placed there. Pick up the sensor on the left-hand side of the table and place it at the end of the conveyor. You also need a sensor to detect when the bag has reached the other end of the conveyor. Pick up the remaining sensor and place it at the other end of the conveyor. Good. Now you must connect the sensors to the digital inputs in the control box so you can use the sensor inputs when you build your program a little later. First, connect sensor 1 to digital input 1. And connect sensor 2 to digital input 2. And just like the gripper, we'll rename them in the software for ease of use. In the left pane, click the I/O Setup button. And then click Digital in 1 in the input column to the left. Rename this input to Sensor 1. Next, select Digital in 2 and rename it to Sensor 2. You can use the inputs from the two sensors to determine when the robot program should turn the conveyor on and off. To control the conveyor, you must also connect it to one of the digital outputs. Connect the conveyor to Digital Out 0. Then rename it by selecting Digital Out 0 in the output column to the right. Rename the output to Conveyor. All the external devices you need are now connected and renamed in the software. You can save these settings in an installation file. To do so, click the Save icon in the header. And Save Installation As. A rule of thumb is to use a naming convention that makes it easy to identify which application the installation file is for. This robot will be picking bags from the pallet, so name this installation file Pick Station. And click Save. In the header, you can see which installation file is currently loaded. Notice how the installation file is separate from the program file. Besides the I/O configuration you just did, The installation file contains any safety settings applied, as well as the configuration of the tool. The next thing you must do is to configure the gripper. But first, let's have a break. What you see here is the control board, which handles all input and output from the control box. Or to put it another way, this is where communication to and from external devices is wired in. The green connectors are for analog I/Os. These can be used to set or measure voltage or current to and from other equipment. The 16 gray connectors are digital inputs and outputs for general purpose, such as sensors, conveyors, and PLCs. The 16 yellow connectors are configurable I/Os that can be used for general purpose, but can also be configured to work as redundant safety inputs and outputs. The yellow I/Os to the far left are dedicated redundant safety inputs. These are for connection of external emergency stop. And these are for safeguard stop, where you can connect devices such as safety scanners, light curtains, and the safety mats. Down here, we have the SD card, which contains the robot image, including the operating system, programs, and installations. To the right of the SD card, the Ethernet port is located. It can be used to communicate with external devices such as PLCs or other robots through common protocols like Profinet, Modbus, Ethernet IP, and TCP IP. Next, you have two USB ports. Here you can connect external storage devices to back up programs, installations, or the entire system. You can also insert a dongle if you want to connect a mouse and keyboard. The last port is a mini display port used to display the teach pendant on an external monitor. That's pretty much everything you need to know about the control box for now. Any questions before we continue? You can think of it this way. Any communication that is sent from the robot to an external device, for example, a signal to a conveyor to turn on, comes from an output, and any communication that is sent from an external device to the robot, for example, a signal from a push button, goes through an input. Good question. As mentioned, the dedicated safety inputs are redundant, which means that any external device connected to these inputs, for example, an emergency stop, is connected by two wires and to two inputs instead of just one. This provides extra safety in case an input fails. An emergency stop is a safety feature that lets you quickly stop a machine or process in an emergency situation. It's usually a red button that you or anyone nearby can easily activate to shut down the machine or process immediately. It's used in cases of immediate danger, or when there's a risk of injury or damage. On the other hand, a safeguard stop is a safety feature that prevents accidents or injuries that might happen while a machine or process is running. It's usually used with other safety devices like light curtains, laser scanners, or safety mats, which can detect when a person or object is too close to the machine. If the safeguard stop is activated, the machine or process will be stopped in a controlled way, so you can fix the problem before restarting the machine or process. Well, in that case, you can connect an external field bus I/O extension unit, for example, Modbus or Ethernet IP. The control board supplies a total of up to 2 amp for external devices. Yes, you can. If you need additional power, here you can connect an external power supply for a total of 6 amp. Yes, absolutely. You can choose between an AC version or a DC version if you need a battery-powered solution. Okay, that was it. And to control all the external devices you need are. The next thing you must do is to configure the gripper. But first, let's have a break.